Bismillahirrahmanirrahim. Welcome dear students to the platform of Quanta Publishers. This is lecture series Teach Yourself, and today our topic is about the integral form of Gauss's law and the differential form of Gauss's law. As we know that Gauss's law help us to calculate the total flux through a closed surface. If you want to calculate the total flux, you can take the help from the Gauss's law. Let us discuss its integral form first. Integral form of Gauss's law help us to calculate the total flux due to the continuous charge distribution. In this diagram, you will see that we have a charge volume that is represented by tau, and the enclosed surface is represented by S. Let us cut out a small differential volume in that region that is represented by d tau, and the charge present in that region is represented by the differential charge dq. From the definition of charge density, we know that charge per unit volume is represented by rho, that is known as the charge density. And if we want to calculate the density in that differential volume that is represented by d tau in the above diagram, so multiply this equation on both sides with d tau. And if you want to calculate the total charge enclosed by that surface S, so integrate this equation, and integration will give us the total charge enclosed by that surface, whereas on the right hand side you see that the integral is performed over a volume and rho into d tau. We know that the Gauss's law stated as the integral upon a surface and E electric field dot dA, the vector area, is equal to 1 upon epsilon naught and the total charge enclosed by that surface. If we use this equation, which is the total charge enclosed by the surface, and put this equation over here, so we have the following equation, whereas you see that on the left hand side the total flux through that surface, which is the integral over E dot dA, whereas on the right hand side you see that the integral of charge density is present, and this equation is known as the integral form of the Gauss's law.